So welcome, Algebra 2 students, to what is probably your first experience with a flipped classroom. This podcast is going to serve as your lesson for the first section of Chapter 9. And what we're going to be doing is taking the things that you reviewed in class last time about factoring and simplifying polynomials, and we're going to apply them to rational expressions. Now before I get started, I wanted to say a little bit about the point of a flipped classroom, and that is to place more responsibility on you as the student to learn the material first, and then having some background in what we're talking about, you will come into the classroom and it'll be my job to be your guide as you work through new problems and get a more hands-on experience with the concepts. So let's get started. Now, whenever we're working with rational expressions, our goal is to basically make the changes in the expression so that we can get it into simplified form. And so that involves finding factors. Now, looking at this definition you can see on your screen, the simplified form of a rational expression is one where the numerator and the denominator, when factored, no longer have any common factors besides 1 or -1. Those are okay. So in other words, if we look at this property, if we have a factor c that is in both the numerator and the denominator, we don't have to keep it there anymore. If we divide that out, we can change it so that just the unrelated factors are present, and then we can say that we have our expression in simplified form. So there are a couple steps that you want to go through in order to reach this simplified form, and the first one is kind of obvious. We need to factor. You're going to factor both the numerator and the denominator first, and then once you can see the factors, you can figure out which ones the numerator and the denominator have in common, and then you can divide them out. In other words, we're canceling them to make 1, and then whichever factors are left behind, you just leave that in factored form, and that's considered the simplified form of your expression. Now, here's a hint. As you're working, do not recombine any of your factors. So don't distribute anything and don't FOIL anything, because what will happen is you'll miss some of the common factors between your numerator and your denominator. If you try to simplify things too soon, you're actually not simplifying it enough. And so keep things in factored form even when you get to your final answer. Just leave things in its factored form. So let's go through an example. This first one here is just simplify one rational expression, just to give you some practice. So here our numerator is x squared plus 2x minus 8. So focusing on that, we are going to have two factors, and both of them are going to start with x, because the coefficient on our x squared term is just 1. Now the other thing we have to think about is we want to multiply our two numbers to make -8, so we'll have one be x plus and the other be x minus. And when we add our x terms, they have to add up to a +2, so we want this number to be bigger than the other one. So thinking about the possible combinations, we see that x plus 4 and x minus 2 will give us the x term and the constant term that we're looking for. Now moving on to our denominator, we actually have something that you may recognize as a difference of two squares. So x squared minus 4, we can rewrite that as x plus 2, x minus 2. Now all we did is we rewrote our expression. So technically these two things are equivalent, so we can use the equal sign. And so then our second step, as described earlier, is to divide out any common terms. And we can see right away that x minus 2 is in both the numerator and the denominator, so they cancel out, and we're left with x plus 4 over x plus 2. And as a final check, we see that neither of those two terms have anything in common, so we can't cancel anything anymore, and therefore this is our final simplified form. So these basic steps that I just went through, they can actually be applied to other situations, and in particular in this section we're covering multiplication and division. There's really only one extra thing that you have to keep in mind, and that is that when you factor first, you then follow that up with multiplying the expressions into one rational expression. So we still want to factor first. You want to avoid multiplying first because that could get confusing. So I have a few examples for you. This first one is just straight multiplication. And the best way to approach this is just to look at our first expression and then look at the second expression. So with our first one, we can factor out in our numerator a 3, and that leaves us with x minus 1. And then in our denominator, we can factor out just an x. And then we have x plus 2 left over. So leaving our multiplication operation there, we're going to move on to our second rational expression and factor that. So in our numerator, we're going to have two binomial factors. They're both going to start with x, just like last time, and there will be a plus and a minus like last time, but this time they have to multiply to negative 10 and add to negative 3x, so we want this second number to be bigger. So it looks like a plus 2 and a minus 5 is going to work. Then in our denominator we have x minus 2 squared, and that looks like it's in its most simplified form, but we want to write out each individual factor, so I'm going to write this as x minus 1 times x minus 1. And this will just be easier for us to recognize where the common factors are and make sure that we don't cancel too much or cancel too little. So these expressions are equivalent, and now since everything's factored, we can go ahead and multiply our numerators and our denominators together. So we'll get 3x minus 1 from the first expression, and x plus 2, x minus 5 from the second. And then our denominator will be x plus 2, x minus 1 times x minus 1. So our next step is to look for the common factors in the numerator and denominator, and it looks like we'll have x minus 1's canceling and x plus 2's canceling, but only one of those x minus 1's is going away. And then we're left with 3x minus 5 divided by x times x minus 1. And like I said before, we're just going to leave it in factored form. We're not going to distribute the 3 or the x. This is going to be our suitable answer for our simplified form. And this last example I have for you is division. So with division, the one extra thing we have to remember is that we are really multiplying by the reciprocal. And in this case, we're dividing by something that isn't a rational expression right now, but we can always change that. We can change that so it looks like 5x squared plus 2x over 1. So in my head, I'm thinking that this is going to be a multiplication of 1 over 5x squared plus 2x. And of course, we're not going to do that quite yet. We need to factor things first, but that's just something I'm keeping in my head, reminding me that that's how division works with rational expressions. Now, let's go ahead and factor. So looking only at our first expression, we have 5x squared plus 7x plus 2 in our numerator. So it looks like we'll have binomial factors again, but this time we'll have 5x and x as our x terms. And it's going to be both addition, because we're adding to 2 and adding to another positive number. So it looks like the 2 can go here, and the 1 can go here, and that will give us plus 2 and plus 7x. Then our denominator is a little bit simpler. We can just factor out an x, and that gives us x plus 1. And then we're going to be dividing by 5x squared plus 2x, and we can factor out an x. So we have 5x plus 2 left over, and that's over 1. So to rewrite that, we're actually multiplying it by that reciprocal. So we'll have 5x plus 2 times x plus 1, and then we're going to multiply by this 1 right here. So that'll be times just 1. and then we're going to divide by x times x plus 1 from our original denominator, and now we're going to multiply that by what used to be our numerator since it gets flipped. So it's going to be times another x and then a 5x plus 2. So now we have everything in one rational expression, and we can go ahead and cancel the like terms. So we have 5x plus 2 and 5x plus 2, and we also have an x plus 1 and an x plus 1. So when that gets canceled, we are left with 1 over x times x. And since these two x's have the same base, we can change this so it says 1 over x squared. And that's really the only time that you're going to combine things again. So you're either going to distribute or FOIL, because they have like terms, so it's just easier to write this as 1 over x squared. So your tasks for the next class are going to be to watch this podcast, which you've already done, and I want you to re-watch it as well. You don't need to take notes, but that might be helpful for when you're working on homework or when you're thinking about the concepts of the lesson. And what I want you to do is bring to class 1 or 2 questions that you have about what you've seen in this podcast. It could be about the concepts that I covered, some of the review things I did about factoring, or any of the examples that I went through that you just didn't quite understand how I got from one step to the next. So bring in those questions, we'll have a good discussion about those. And then I also want you to look at pages 558 and 559 in your textbook. So this comes from section 9.4. And out of the problems in that book from 16 to 49, I want you to pick 2 that look like they might be a little bit more difficult to start. So if you're looking at it and you think, oh, there's way too many numbers involved, there's way too many coefficients, or there's too many terms. If you think they look difficult, write them down, bring them to class, and then I will pick 3 out of all the problems that you bring together, and I will go through those on the board, we'll go through them together, answer any questions you have, and then hopefully this will help you get started on the problems that we'll do in class as well as your homework.